This is section 2.3, the fundamental theorem of variation. The fundamental theorem of variation tells us if we have direct variation, y varies directly to x to the n by some constant k, and x is multiplied by c, then y gets multiplied by c to the power of n. If y varies inversely to x, and you can't really see my, let me make this fraction sign a little bigger. Y varies inversely to x to the n by some factor of k. If x is multiplied by c, then y is divided by c to the n. What this basically tells us is if we're using direct variation, whatever operation happens to x, whether it be multiplication or division, happens to y. It just happens to the power of n. If it's inverse variation, then whatever operation happens to x, the opposite will happen to y, just by the power of n. And let's walk through two examples together right now. Given that d varies directly to s squared, it's just being divided by 10, prove that if s is quadrupled, d is multiplied by 16. Everybody take a peek-see at this equation and agree with me it's direct variation. Both of my variables are in the numerators. I just have a constant in the denominator. Be careful of that. Now, if s is quadrupled, that means that s is multiplied by 4. So let's go ahead and plug that in. D equals 4 times s now, to the power of 2 divided by 10. When I simplify, I am going to get d equals 4s times 4s. Agreed? And when I simplify again, I get d equals 16s squared divided by 10. Look at this equation versus this equation. They're both exactly the same, except for now my output has been multiplied by 16. So if s gets multiplied by 4, d got multiplied by 4 to the power of 2. I multiply s by 4, d gets multiplied by 4 to the power of 2, or in this case, 16. Now for example number 2, we're going to go ahead and go back to the fundamental theorem, and we're going to use that to answer this question. If we're not asked to prove something, we're just asked for the effect here, we're just going to use our theorem. We're given the formula for intensity of light. Intensity varies inversely as distance squared, and we want to know what effect doubling the distance has on the intensity of the light. So if I double my distance, that is actually multiplying by 2. Now, since this is an inverse variation equation, I know that the opposite is going to happen. Instead of multiplying by 2, I know that now the intensity of light is going to be divided. The opposite happens with inverse. So I'm going to say divided by 2. And it's not just 2. Remember, we need to take into consideration the power. So it would be divided by 2 squared. So since it's an inverse variation equation, since I'm multiplying d by 2, I gets divided by 2 to the power of 2. So remember, when your variation is direct, the same operation happens, it just happens to the power of n. If your variation is inverse, the opposite operation happens also to the power of n. What I'd like you to do for tomorrow is look at this example of direct variation and this example of inverse variation. And tell me for each what happens when x doubles, triples, or is halved. Remember, being halved is like being divided by 2. And I want those set of 6 questions at the beginning of class tomorrow, and I'll see you then.